Hi everyone, welcome back. So in this video, we're going to talk about ADAM training. So basically, it works for the building a subject level analysis datasets, and this will be the module 2. So this training module will guide you, the clinical data programmers, through the structure, purpose, and implementation of ADSL datasets according to the CDISC ADAM implementation guidelines. Okay, so next slide. Sorry. So this content for this training module will be ADSL. So basically the content will be providing the training related to the all the relevant sections, ADAM model and ADAM implementation guideline, and it is recommended to reference the following material for the training sessions. So you have the versions 2.1 model version 2.1 and section 4.2.1, that is the ADSL structures. So if you have ADAM implementation guidelines, so you can go through the section number 4.2.1 where you can have ADSL structure. Okay, and also in the guide version 1.1, if you check the section 3.2, you will be having the ADSL variables. Sorry. So not for the CDISC ADAM terminology, the references of the latest versions. However, for these each individual study, the sponsor should confirm, like, the version of the CDISC terminology to be used to start off the study. Okay, so this class will be going into further detail on ADSL and the types of data going into the dataset, how they differ, from other structures in the ADAM model. So each section will consist of the range of variables in a specification format, some discussion regarding, key point for each set of variables, and some examples. Okay, let's go into this module class. Okay, so the training module contains in this video will be having the purpose of ADSL, and understanding the foundation of role of ADSL in clinical data analysis, and I will be having the identifiers and demographics. So the next that would be the subject identifiers and demographic variable structure. And the number 3 will be the population indicators. So basically we flags that identify analysis populations, and we'll be having the treatment variables, so the timing variables and disposition variables. So all these are variables, or different different sections of the variables will be present in the ADSL data structures. So we will be conclude, we'll be having some quiz in the, this depends, we can keep it or not, so we'll try it some. So let's continue with the next slide. So basically, what is the purpose of ADSL? So the ADSL dataset is to create as a dataset contains, all the subjects of level of analysis information needed for the study and in a single place. So the basics of starting to create ADSL dataset in the SDTM demographic datasets. The dataset basically contains required variable as well as relevant information, subject level information. So such as the population flags, discontinuation from, the treatment start and end dates, and the ADSL is basically, it requires the dataset in CDISC based submission of data. So we'll be having the population flag and the treatment and information. So it is routinely merged with other analysis. We'll be having the data sets called basic data structure and occurrence data structure to provide a consistent demographic treatment and a population information. Okay, so next we continue with the identifiers. Okay, identifiers and demographic variables. So ADSL contains all needed demographic variables for subject in one place. So this negates, the need of random dataset to be set up. Basically, if you check the identifiers, identification will allow further information about the site subject to be collected. And in the demographic data, like the grouping variables, you have a grouping variables here, right? So we'll be having age related subgroup analysis, ADSL ones that can share along other columns, other domains. So in the demographic data, we'll be having all the demographic information. So the basic demographic information required: age and sex, gender of the subject, and race. This information will also be present, and these three categories will be considered identifiers demographic variables. Okay. So these are the some variable names which have identifiers and demographic information. So these are common variables for core identification and demographic profile. Study ID, subject ID, site ID, age, sex variable, race. So what is the label of the variable and the type and the core that is required. So basically these seven, 1, 2, 3, 4. So these 8 of them are required variables. So it should have to be present in your data structures. Okay. And when you come to the so for the permissible demographic variables, there are some pooled site variables, the site related information. So this is the optional sections, in the identification demographic variables list for the cover for analysis version of the previous variables. So for site, region, and age, race groups, they are y refers here. The y refers to the method used in the order to group the information as opposed to specific hierarchical grouping of the information. For example, if you want to check the regions based on Europe against all others, that could be region one, region one, region two. The Asia will be considered as region two. So we give you the number on the y consider will be as a number. That is not to say that Europe grouping takes precedence. So it fits the decision making for region two. And and AH analysis, AH is the most common deviating analysis variable used in demographics. So this allows algorithm to be used in order to show age of the patients during the study. For example, if you want to know the age of the patient, randomizations, we could use BUD DTC, or you can use randomized date instead of the CRF entry, so which would normally be informed consent. Okay, so let's continue with the next slide. Okay, so here we'll be having a multiple age grouping strategies. So age group 1, FDA required less than or equal to 65, less than equal 65 and greater than or equal to 65. And age group 2, the protocol specific will be having consider this range will be considering the age group 2, and the post hoc analysis indicates 18 to 29, 30 to 39. So that will be considering as a age group. So each group has its corresponding numeric versions. Age group number 1 numeric format, like that. So the different analysis, so for each individual range will be considering one group. Okay, so the next one will be the population indicators variable. So here the population indicator variables defined which subjects are included in specific analysis populations. So these flags are crucial for ensuring the statistical analysis are performed on the correct subset of subjects. The population indicators are typically represent yes or no character variables in the ADSL datasets and serve as filters for statistical analysis. Okay. So here ADSL contains number of population flags. So Adam IG contains common population flags to be included, but any population flag that is needed based on your analysis would be derived on in ADSL. Okay, so you can have a different population flag as per the company required. So these are the some set of population indicator variables usually you can encounter from the ADSL. So you'll be having the full analysis set population flag and the safety population flag, intended treatment population flag, per protocol population flag, the completion flags, and randomization flag, enrollment population flags. So all of them are conditional, so it's based on required by the study. Okay. So here the common flags include, so you should have yes or no. So if the trial you are working randomized, then randomization flag will be required for the variable. So if the subjects are considering in under the safety, so we have to filter out those populations having safety population flag equal to y. Okay, so next we go to do the treatment variables. So here okay, so here some of the hierarchy of the population flag typically follows in the nested structures. So you'll be having a per protocol flag, then full analysis flag. So basically you need to check the consistency, verify that population flags are consistent with the protocol definitions. So make sure you have all subjects have appropriate population assignments. Document exclusion reasons for subjects not included in the specific populations. So the cross-check population counts against the clinical study reports. So the proper implementation of population flag is critical for regulatory submission and accurate statistical analysis. So it's just a hierarchy. There is no kind of significant of having this nested. Okay, so we continue. So here we'll be having the treatment related information, treatment variables, sorry. So ADSL is able to show the treatment variables that explained planned treatment for the lifetime of the study, as well as the treatment that patient actually took. Okay, so the TRT information can be shown on study-wide basis for subject. So it can be split out, split it down into what was taken at individual period basis. Treatment information can also be shown on the training. We will be focusing on, shown on the pool basis as well. So if you are interested in pooling treatment together, in case we want to look at all the doses of drug 1 compared to all those of drug 2 as an example, for the purpose of the training, so here the treatment will be considered, in the pooling studies. So the treatment variables must accurately reflect the study design, including the single period or multi-period period or crossover trials. Okay. Okay, so the next one would be, so here will be, you see here, the course specification will be having a three different set of categories. The arm variables, is a description of the planned arm, so it is required, and the character format. And the actual arm, the description of the actual arm, so it is a permissible variable and it is a character format. So these variables describe the overall treatment arms assignment for subjects, and so there are periods, the x-axis represents 0 1 0 2. So if you have a two periods, you can TRT 01P and TRT 01P and in the numeric format. So these are the planned, the P represent the planned treatment for the period, required variables, and it is a character or numeric, because the TRT 01P is the character format, TRT 01P and it will be the numeric format. And it is the same thing with the actual treatment for the period, and this is a planned as per the protocol, and this is the actual the treatment has given to that particular subject. Okay, so these variables capture treatments administered during the specific study of the period. So the treatment sequence in the planned version and the planned in the numeric format, this is a conditional variable. So it will be having other, the character and the numeric. It will be having both character and numeric, and also will be the same for the actual ones. So critical for crossover designs. This is mostly it works for the crossover designs to track the treatments of received. Okay, so next one would be, so this is an example how it looks like for the treatment related information. So this is a single period trial, so you'll be having the only three steps, three phases in the screening and the treatment and the follow-up. So in the treatment you will be having only the TRT01P and the arm, the drug you are going to use it, and the TRT01PN. So we'll be having one treatment. Okay, so if you have a multiple periods, the crossover trial treatment, so here we'll be having the washout, then come back with the TRT, the period 2, then we'll be having the follow-up. So there will be the two periods. So you see the TRT01P and TRT01A and the TRT02P, TRT02A. So how we represent in the treatments if we have a multiple crossover studies. So here we have the subjects, unique subject ID and the drug and the TRT-P01, TRT-01A, 2 P's like that. So no treatment deviation in the subjects. So where actual treatments, so you see here 002. Okay, I don't have 004, where actual treatments differ from the planned treatments, highlighting the importance of the capturing both planned and actual treatment administration. So you can have the importance you see here. Here they have given treatment 1, and here we'll be having treatment 2, and here we'll be having treatment 2, and here we'll be having a treatment 1. That is like kind of crossover study. So how it looks different, you see here. For example, when you see in the TRT for 002, TRT 01, the plan one have as per the protocol, they have mentioned for the TRT treatment 1, but in actual they have given treatment 2 for this patient, for the subjects. And for the period 2, they have planned for TRT 02 treatment 2, but they actually have given the treatment 1. So that is kind of deviating, but deviating to the protocol. So this kind of we can able to recognize, understand this part from here. Okay, so the next one would be the timing variables in ADSL data structures. So the timing variable, the purpose of the variables document when the treatments are administered and track study periods, creating an accurate chronological record of each subject participations. So the categories, so these variables include treatment timing, period timing, and phase timing measurements across the clinical trial life cycle. And the importance of these precise timing argumentations is critical for statistical analysis and safety monitoring and regulatory compliance. So these timing variables in ADSL allow for the imputation. So exposure information can be imputed based on any needs for analysis. Okay, so if you continue for the timing variable, so here we'll be having the treatment timings variables documenting first and last exposure of the study treatment. Okay, so the period timing, the variables defining analytical periods within the study design, and the phase timing variables tracking broader study phases across the clinical trials. So each category follows standardized naming conventions and contains both required core or conditional and optimal permissible variables to ensure consistent data representation across study. So in these timing variables, you'll be having three categories: treatment related timing and period, like what is the period, like which period, period 1 or period 2, that is the timing, and a phase, what is the phase of the timing. So these variable have present in the ADSL data structures. Okay. Okay, so next one would be, so you see here the TRT start date of the first exposure of the treatment, which is in the conditional, and the time for the first, this is related to the treatment. This the TRT SDTM, TRT EDT, TRT 01 SDT, TRT 01 EDT, all this related to the treatment timing variable specifications. So must be populated when dates are partially known and require imputation with values SR, S, E, S, Y for the year, M for the month, and D for the day. Okay. Um, so So the treatment timing variables in multivariate crossover trials. In crossover design, subject receive different treatments in sequence across the multiple periods, requiring precise tracking period specific variables. So you see here in the TRT, in the treatment one and the treatment one has given both in planned and actual. You see the start date is 2019 and end date will be the 8th of, so like almost like 1 week after the TR treatment has completed. When you come to the period 2, so the treatment was started on 2019 September, so it's almost another after 1 week, and it end with after 1 week. So in the TR in the for this subject 003, the TRT treatment 2 has given both the plan as per the plan and as per the actual has given, and this also considered have the different timings of the TRT. So the next one would be the treatment timing variables with imputation example. So here we have a TR02 EDTF, the flag we have to flag, because when you check the patient number 2 in so we can use the imputation variables provided for the 30 September 2011 29, because this is the partial date, the day is missing. So what we did, we imputed, because this is ended date, so we imputed with the end of the month, and we have given the flag as a D for the day, and the TRT EDT will be having the ended that the treatment end date will be having the final end date will be having the imputation date. So notice subject has so this is the one, and overall timing that represent the overall first and last exposure of the dates across all periods. The TRT EDT will be the final one, and the TRT SDT will be the first period of start date. Okay, So this is the difference between these two. TRT01 SGT is different, TRT02 SGT is different, TRT SGT is different. So this is overall dates across exposure dates across all periods. Okay. Okay, so next we continue with so subject level period timing analysis. So here we have a period timing variables to track the start and end of defined analysis periods. So AP01 SGT, AP01 so EGT. So these are the analysis periods for the period time. So each period can have its own timing variables in ADSL. So there are different, the first date or time exposure as it covers the treatment periods that have been defined in other variables or in your study design. Okay, so you can also see this imputation flags. So for the date or time imputation with flags indicating the level with the precisions, year, month, and date for dates, hour, minutes, and seconds for the times. So for the date and time variables, combined date or time variables should be created when both components are collected. Okay. Okay, so the next one would be, so you can see the subject level phase timing variable. So here we'll be having the screening phase. The screening phase will be having this A phase 01 and the phase 1 start date and phase 1 end date. So the track the initial screening period before randomizations, and we'll be having the treatment phase here, that is A phase 2. The phase 2 start date, phase 2 documents the active in treatment intervention periods, and the phase 3 will be the follow-up phase. Okay, so these are the variable you can see these are the differences between different phases. So here the disposition variables, the next topic will be the disposition. So the disposition variables are designed to provide further insight into what happened to a given patient during the time that they were on the study. So go some way to describing the subject experience during the many periods, the phases of clinical trials. So we'll be having a study completion status, a reason for withdrawal, protocol deviations, and analysis population flags. Okay, so this example provides the setup of an ADSL dataset for 4 patients. So that shows how disposition information can be displayed in the various scenarios. For example, if we check the subject 001, so we are able to see the end of study status variable that have the completed the time on the study as expected in the study designs, and then no further information is required if a patient has been marked as a completed. So other than that, at the date at which they are completed, this has been entered in the end of studies date. Okay, so we can see that patient has also completed, the treatment has been as expected. So completed in EOT STT. So for the, if you check the subject 2, so we can see the subject discontinued the study early, so therefore the marked as a discontinued. In the end of study date time, so it will be giving as a discontinued. And for the subject 3, we do not have any completion or discontinuation information across the study or treatment status. Without this information, so we have to assume that this patient is still ongoing in the study. So in order to show this, we can set both EO STG is ongoing and ongoing here. And for the last, we can, the subject 004, we can see a discrepancy between the study status and the TR treatment status. So for the study status, for the subject is completed and a given completion date of 07 October 2019. However, the treatment status is discontinued, and the reason is the enter as the other. So he do in the DSTRTES the variable. So other is included. So we can utilize this reason plan so variable to provide the further information relating to why the treatment status is discontinued. So that is Mr. Schedule visit. So this example highlights the fact that end of study status, end of treatment study status are not required align. It is possible that you can complete the study without completing the treatment regimen, or the vice versa. So when you come to the next slide, so the disposition data flow, so we'll be having the source document, so either the case report forms and electronic case report forms and clinical notes containing the raw disposition information. So this will be a vital information for doing the DM data set. So DS domain. So capture dispersion information data. So DM domain contains demographic and enrollment informations. Okay, so based on these two domains, DS and DM, so we can create a consolidate the standardize in ADSL data set dispersion variables. Okay. So the next will be so the key consideration for the ADSL discussion. Now that we have discussed many of the sub-specific variables that go into the ADSL creation, so it is important to note some of the items that are worth considering as you go about compiling the specifications. So here, the many of the variables are based on the study design and knowing the periods and time point. So needed for analysis. Therefore, it is important to have a clear understanding of the protocol and SAP, so you are able to understand the period and phases of analysis in order to select the right variables. So basically here we have a data and consistency. So ensure all dates are used in consistent formats and imputation methods for partial dates. And the variable completeness, all subject must have appropriate status variable populated regardless of the completion status. And the protocol alignment disposition category must align with the protocol defined discontinuations criteria and SDTM traceability. So the maintain clear derivation for paths from source SDTM variables to ADSL disposition variables. So the proper implementation of the dispersion variables required careful coordination between data management and biostatistics teams to ensure accurate representation of the progressions through the study. Okay, so this is the end for the class, the part 2. So we'll be continuing for further classes. Thank you so much for listening.